All right. So you'll notice there's a word on the slide that might invite some skepticism from the audience. That's okay. That's encouraged. I thought maybe spelling it out the whole way would throw a couple folks off. So today I'm going to talk to you about using AI to reduce toil in detection writing. So quick agenda. I'll go over who I am, and then we're going to talk about what a large language model is. So that's the particular flavor of AI that we're going to talk about today, right? And then I'm going to go into what I consider is the status quo with detection writing, the problems there, and then we'll see if this is a technology we can use to solve some of those, right? But most of today, it's really just going to be showing you real-world experimentation, the results, really just techniques and tips for how to build with LLMs, okay? I really wanted to put this talk together because I wanted a resource that I think would have been super useful to me 6 to 12 months ago when I was first learning how to build with all this stuff. So if you take away one thing from today's talk, I just hope that it's straight up practical advice, right? I want this to serve as a how-to guide. So we're going over one use case in particular, right? But think about your day job, think about opportunities that you could take this, what you learned today back to that, right? So my name's Dylan, I work in security operations, so typical blue teaming stuff, right? A lot of the stuff I do now is around cloud, but really outside of that, I spend most of my time giving folks practical advice on how to build with LLMs within our domain, right? That's kind of the whole point, and I want to show you today that the game's kind of changed. You no longer have to be like an AI or a machine learning expert. We have this opportunity with this technology to apply it to our field. So that's kind of what today's going to be about. But if you want to connect with me, just hit me up on LinkedIn. That's typically where I hang out. That's also where I do regurgitate white papers if you're into that sort of thing. So raise your hand if you use ChatGPT, Claude, Gemini, Llama on a daily basis, a weekly basis. Okay, a couple folks, right? So raise your hand if you use ChatGPT to write emails to your boss. Okay, yeah. I'm looking for my boss. He hasn't caught on yet. So, okay, so we've had this explosion of generative AI, right? LLMs, large language models, I think it's coming up on 2 years now since ChatGPT came out, right? But let's talk about like what is it? Like what are these things, right? And so this technology is not necessarily new, right? So LLMs come out of a field under the umbrella of AI called NLP or natural language processing. And you're probably already familiar with using them, that they're really, really good at two things. One is understanding natural language or text, right? And the second thing is generating natural language or text. And I want you to remember that term generative, right? It's the G in ChatGPT, generative AI, right? So these models were built and designed to spit out text. And really the way that they do that is just based on two things. One is the data set that the model was trained on. So in this case, large language model. Think of a super large corpus of text like all of Reddit, all of Wikipedia, right? And the second thing is just the text that you give the model in that prompt or that question that you give it to it, right? So using these two things, we're going to keep it super high level. All it's really doing is it's going, hey, what's statistically the next most likely word or sentence or phrase, right? So keep that in mind. And a great way to kind of think about this is imagine I ask you to write an essay on your laptop, right? But you can't use backspace, okay? It's next word, there's no going back. So keep that in the back of your mind. Let's get into, okay, so you may hear folks refer to them as they're being non-deterministic. What does that mean? It just means that they're random. Not random in the sense that if I ask it a question, print the number 1, it goes 1, next time it goes piss off mate, or something like that. Not that random, right? But if I ask the same exact question 2 times in a row, I might get 2 slightly different answers, right? But that's not great from a software engineering perspective, is it? So just understand some of these guardrails in place when we're building around LLMs. We can never really trust the output 100%, right? And we'll get into that later. So with that said, what's the one thing we can kind of control? And that's the text going in. And that's really what a majority of today is going to be about, right? I'm going to keep it really simple. When you're building with these, I just want you to think about text going to the LLM and text coming out. That's it. So why is this such a big deal, and why should you care? Like, why should we care about this stuff, right? So it really comes down to 2 things. The first is that these models are obviously more capable than they've ever been, right? And they're available to the general public. So you have a phone, you have a laptop, you can even run it locally if you want. And the second thing, which I think is the bigger deal that I want you to understand, is that we can shape or modify the behavior of these models considerably without doing any training, right? We're not training the model, we're not mutating the model, we're not touching it at all, right? So keep that in mind going forward. This has lowered the barrier to entry dramatically. You know, before you would have had to get in a group of machine learning experts, a team, stand up infrastructure, get data, clean the data, all these data science problems, right? So think about that. Okay, so the title of the talk was, can we use LLMs to maybe get rid of some of the toil involved in writing detections? And so let's break down that word toil really quick. So just think of work that tends to be super manual, repetitive, right? It's devoid of value. So things that are kind of a pain in the butt, but you got to get them done to complete the overall task. So think back to your day jobs. Think maybe some things pop into your head as candidates for toil, right? And so when we talk about writing a detection, it's really just this journey of going from an idea to a finished analytic, right? But what I want you to take away from this slide is that this involves a lot of different areas of expertise, right? It's a lot of different areas of specialized knowledge, a lot of manual steps, okay? So to illustrate this, let's just walk through a quick example, right? So we have an idea for a detection. Let's say you read a tweet, Reddit, a blog, right? Attacker shares EBS volume with another AWS account. So first thing first, we got to go like, what does that even mean? Like, what's an EBS volume? I don't know. Maybe I don't know, right? We got to understand the tradecraft. Like, why is this bad? Why do I want to write a detection for this? And that's a form of expertise in itself, right? And then typically we go, okay, what security data, what logs do I have to catch this thing? And there's a multitude of attack surfaces, right? We have endpoint, we have network, we have cloud, we have SaaS, right? You have to understand all the nuances of those logs, what the fields mean, what the values are, right? And then typically there's some step of crafting a search, right? We have to interact with the data somehow, right? You may have your security logs in a SIM or an XDR, a data lake, right? But now you have to know a domain-specific query language. So think SQL, Splunk, SPL, Elastic, right? And that's a form of expertise in itself, right? And so then there's typically some tuning, right? Excluding benign behavior for your organization, right? And then the last step is writing the actual detection. And so StreamAlert is one way to write detections. Just keep in mind for any of these steps, you can swap it out with whatever tool or technology that you're using, right? But what's cool about StreamAlert is that a finished detection for us is not going to be one, but it's going to be two things, okay? One's the actual detection logic. What does that mean? It's the conditions that I want to fire an alert, right? So just think event name is one of the following, username is not one of the following, right? And each detection in this case is going to have a matching unit test. And all this is logs that are going to trigger the alert, a true positive, right? And logs that are not going to trigger the alert, a true negative, right? But take a look. I mean, that's a lot of toil, right? And I know this will resonate more with the SecOps people in the room, but this is pretty painful. And it's not necessarily linear. There's a lot of going back and forth, right? Debugging, tweaking. Okay, so now the question becomes, hey, can I, as an analyst, type out in natural language an idea for a detection or hand over something like a report, right? Can I just use the multitude of open source threat intel that's already out there? There's some really good stuff already out there, right? Can I hand this off to an LLM and have it do a majority, if not all, of that work that we just showed? So that's the hypothesis here. Keep in mind, we're still going to have a human in the loop. We're the expert, right, at the end to look at the final work product and approve or deny, right? Okay, so if you remember back to earlier, I talked about what's the one thing we can control when we're working with these models. It's just the text going in. Folks may have heard the term prompt engineering. That's what this is called. But I just want you to think of it very intuitively. It's how can I get the LLMs to do what I want, right? And we're going to break it down into two sections. We'll do some basic techniques and some more advanced ones. There's some nomenclature on the screen. I'm probably not even going to use it. I just find it's a very fancy way of saying stuff that will come very intuitively to you because we use natural language every day, right? Okay, so we start. We typically encounter like a blank page problem, like I don't know what to write in this prompt, right? If you think about it, ChatGPT, it's like this text box. There's no instruction manual, right? So my advice to you is use the LLM to write the prompt. They are just as good, if not better, than humans. So, use this as your first draft, and it's not going to be a one and done thing. You want to iterate with it, right? So just like I'm talking to you now, you have an idea for what you want to use this technology for, right? Start there. And what I want to show you here is that kind of the meat and potatoes of what you should see in these prompts, right? This is all free-form string, system prompt. So think of drawing lines in the sand for the actual task. You're an expert threat hunter. This is what you're going to do. This is exactly what you're going to do, right? I'm going to give you some examples. I'm going to give you step-by-step instructions, right? And then there's going to be guardrails. Here's what I do not want you to do, right? A better way to articulate this, I think, is just ask yourself, like, what would you give a new teammate or an employee, right? Imagine these pre-trained models more or less have like basic security fundamentals down, right? They know what AWS is, they know what a network packet is, but they might not know all the nuances, the data at your organization on how you do certain things like writing a detection, right? And so just sit down and write out step by step, get as detailed as you can if you had to give these instructions to a new hire, right? And to test this, just go give it to one of your teammates. And if they can clearly follow it, right, there's no confusing parts, they're generally a good sign you have a good prompt, right? If you want to take it a step further, give it to somebody outside of your department. If somebody who's not an InfoSec can do something like this, you probably have some pretty damn good instructions. So, okay. So as you can imagine, these prompts are going to get pretty big, right? I mean, we're working with security logs, security analytics, a lot of steps. And typically, it's okay to have prompts up to thousands of words, but we don't want to get too big, right? We don't want to get too complex. So when this happens, structure. Be clear and organized, right? We don't just want a bunch of jumbled up free-form string. Say threat intel is here, the detections are here, your QA criteria is here, right? And break up expertise. So we don't want to give too much complexity in one prompt to the model. We can use multiple prompts, and I'll show you that next. So just keep this in mind as you're building these out. This is a big one, and it may sound kind of silly, but people talk about hallucinations a lot, which just means the model fills in the answer because it doesn't have the correct information. It's going to be inaccurate. We don't want hallucinations, right? Give the model the opportunity to say, I don't know, or to just not complete the task. So for our use case, if I only care about cloud or network threat intel, and I give it a bunch of Windows stuff, I don't want it to finish the task. Just say, I can't finish the task. I don't have the proper info, right? And exemplar selection. So this is by far the biggest lever you have for quality. You are much better off picking 3 to 5 really good, diverse examples, edge cases, than picking like 100 randomly selected ones, okay? Remember, you're the expert. You know what looks good. So spend time to handpick those examples. It will really make a difference. As we're iterating with this, right, start with the bigger models, the more capable ones, right? Claude 3.5 Sonnet, GPT 4.0. When you're ready to start moving this into like a normal process, you're using it every day, move to the smaller ones. So with the techniques that I hope that you've learned today, if you're doing them properly, the smaller models for a majority of use cases should be more than capable to do a lot of these computations, okay? And what's great about the smaller models is that they're faster and they're more cheaper, much cheaper. So, over here, top left, bigger, more expensive, slower models, right? Try to move to the green area. Claude 3 Haiku, GPT 4.0 Mini, Gemini 1.5 Flash, and I'll show you later some of the actual numbers on pricing and stuff. Okay, this shouldn't be a surprise, but it's like a lot of other technologies, right? Garbage in, garbage out. If you are having trouble with quality, consistency, accuracy, you're getting hallucinations, it's likely going to be one of 3 things. You have a bad prompt, okay? Your prompt is too complex, it's too big, or the third thing is it's bad input. And so what's bad input for us? It's bad threat intel. should I be surprised if I give garbage threat intel to an analyst and they can't write a really well-written detection? I don't know. So look at the input too. It should be clean. It should be organized, right? So just keep that in mind. Okay, so that covers more or less the basics. Let's get into a little bit more of the advanced stuff here. So you remember this workflow from idea to detection earlier, right? This is a complex task. So what we can do is break this down into subtasks, decompose it, break it down, right? And write a prompt for each one of these steps. And we're just going to chain them together, right? And so when you do this, this is when things start to get quite powerful. These models are really, really effective at doing one specific thing very, very well. So think about specialization in each of these steps, right? Okay. So just to see if folks are paying attention or learning, we're just going to do a quick game. Good prompt, bad prompt. I'm going to read the prompt. Just yell out good or bad, okay? Write me a detection for when somebody is wreaking havoc in my AWS account. Is this good or bad? Bad, right? I might want to know this, but it's not a good prompt. Why? It's ambiguous, right? We didn't use any of those instructions, those tips we learned. But if you think about it, this could mean 1,000 different things, how you want to interpret it, right? It's not very clear, okay? Okay, write me a Splunk query for the following: threat intel, actor was found disabling CloudTrail logs, guard duty. Here's some examples, and those are 2 Splunk queries. Is this a good prompt? Bad? Good? Better, right? Better. We're being specific. I'm saying write me a Splunk query. I'm not just saying detection, right? The examples look good. Let's assume they're good examples, right? Better. But the threat intel, not great, right? Bad input, more or less. So I would still call this bad, but a little bit better. Okay, you're an expert security analyst, and your task is to extract TTPs from threat intel into viable candidates for detection logic. And then we have some Okta threat intel, it looks like, clear sections. Is this good or bad? Good. Better. Not perfect, but much, much better, right? We're being clear with the task, giving it a persona. We're saying exactly what you're going to do. Here are the detections. Here are the logs. Let's assume they're good examples, right? Okay, so let's start to put this all together. So I created an open source tool. I'll share the GitHub link at the end, called Diana. And so really this is about, hey, we have a threat research report here, or a blog, whatever you go for your detections. So we can sit here and read this, or what we can do is use this tool. We're going to pick our LLM provider, right? Anthropic, Bedrock, pick the model, right? GPT-4, and then we're going to pick our security data or the logs that I want to write detections for, right? And then we're going to pick our detection language, right? Okay, and then we're going to give the report to it. You could scrape the URL if you want to. You could write out in natural language the idea you have for the detection. We're going to hit process on this, and it's going to go, hey, I found 6 candidates for detections, right, that you might want to look at. So we're just going to pick one here. And then hit process, and then off we go, okay? It's going to create the rule, investigation, a triage guide if you want, right? It's going to do some QA on it and put it all together for you at the end. But that was pretty quick, right? So what I didn't show you for the purposes of time is that when we're using the tool, remember, we're giving it good quality examples of our logs, of our detections. Maybe you already have step-by-step internal documentation on how to write a detection, right? But what I want you to take away from this is, based on that info that you're giving to it, all that's really happening behind the scenes is a lot of these prompt engineering techniques that we just went over, right? Okay, this is cool and all, but I bet you're like, hey, is this thing accurate, right? That's what I would want to know, right? And so I'll show you 2 evals I did. And the first one, I just picked 50 randomly selected techniques. These would be behaviors that threat actors were using that we might want to write a detection for, right? And 42 out of 50 passed. And what does that mean? So remember from earlier, for us, detection is going to have a unit test. It's either going to pass or fail. And that's a great way to do a really quick and dirty test, hey, generally how accurate this thing is, right? And so, 8 out of the 50 failed. And I can already tell you just by looking at the results, it was usually because me as the human, I just didn't give enough good context for the model. It hallucinated, filled in a log field. Well, I didn't give it that log in the first place, right? So this is great, but this still doesn't tell us stuff like, how well written was the detection? Did it reflect the threat intel, all of it accurately, right? Was the query performant, right? Stuff like that. And so for this, what we can do is use an LLM as a judge. And so all I did was I added a step at the end of this workflow using a bigger model, and I gave it a very, very specific criteria of what I think is a good detection, right? And what I want you to take away from this is that the reason I'm doing this, instead of using humans manually, you can start with that in the beginning, but that doesn't really scale, right? We don't want people sitting here sifting through hundreds of outputs, grading them. But this should be no different than, let's say a professor or a teacher is grading a paper of yours, right? They do it based on two things generally. One is the rubric, and one is their knowledge or experience, right? So sit down, and you're the one who's going to pick what good is in this rubric, right? So some things I put in there, analytic robustness, threat intel fidelity, you get the idea. So try your best to align the LLM judge to what a human subject matter expert would do, right? And on the right here, we can see there's a box plot of the scores. So this one, I think I did 100 techniques, and there's a screenshot of how much it costs here. And so remember, the LLM judge is the bigger model. It's like almost $2 there. But the majority of the processing of this tool with Mini, the smaller model, is 19 cents. So 100 TTPs in cost me 19 cents, right? And why am I telling you this? So don't use one or the other of the evals, use both, right? We want to use a healthy mixture of both. Stick to the deterministic methods, right? Unit tests, assertions, and then use LLM as a judge for things that are harder to put a number on, right? Things that are more subjective. Okay, so for example, let's just say we want to write 50 detections. It's going to take us 200 hours. Now, using humans with LLMs, we can shave this down to 36 minutes, right? And this is great because it's not perfect, but hey, that saves me 80% of my time. That's 80% extra free time for my team, right? This is great. So let's start thinking about what is possible. We've spiked this out. We get it to a place where we're happy with the results, right? Now we get to an area where humans just can't compete, okay? And that comes down to two things. It's scale and speed, right? So I want you to kind of think of this workflow that we went through today as like intelligence pipelines, right? It's up to you to articulate those steps. That's the key. So now the question is like, hey, why can't I just take 100 or 1,000 sources for threat intel or do this all the time? Hey, pick out every single good detection or analytic for me, right? And where is this going? So, we can have a human use this tool ad hoc, right? Kind of like as a workbench. But why can't I just scrape the threat intel straight from the web? I have RSS feeds. Sure, why don't we just do that, right? Why can't we have the LLMs do the research for us? Sure. And if you remember today, so at the end, we have this query here, right? A human's still got to take that and go look at their SIM, do some tuning, right? That's still a human step. Well, why can't we have an LLM do that? Sure, we can. And then really it's up to you on how you want to consume this, right? There's still a human in the loop at the end, right? You're the expert. You're going to look at the work product and approve or deny. Create a Jira ticket, Slack message, send it to a GitLab pipeline, right? But what I want you to take away from this slide is that, remember, each of these steps are handcrafted through hours of iterations to be experts at that one particular job. That's the key to these complex workflows, okay? So just some closing thoughts. The way I think about this is it's really making users power users, right? So it's about making one or two people equivalent to 3, 5, 10, right? With that said, AI is not a panacea. Don't throw it at everything, but it is a lever, okay? And a lever should be applied strategically, right? So you go out into your org, look for that toil, and this is a tool that you can use to maybe help with some of that. So I think what you'll learn today is sometimes when you're building with LLMs, it really is sometimes more of an art than a science, which is funny, right? So there's the link for the tool on GitHub up there. The second link I put there, I get a lot of people ask me, where can I go if I want to start learning how to build with these? And that's just a culmination of resources I've found over the years. Blogs, videos, if you're a video person, papers, stuff like that. So that's a really great place to get started. So I think that's a wrap. Cool. I think we have time for questions.
Yeah. How do you, so if you're using this tool, do you input like Splunk logs, or do you input like raw sysmon logs kind of? Like which one is better? Is it better to input like, you put like raw Windows event logs or sysmon versus like your Splunk logs? Because the logs are slightly different depending on what
Right.
source.
Yeah, so it's really up to you. So like I would think of it about what is the human doing when they're writing detections, right? Are they looking at, sounds like you're talking about the normalized logs, right, that you would see in a SIM like Splunk, instead of the raw logs as they would exist from the log producer, right? I would use the normalized logs, like the ones that have the field names in there. That's what the human would be looking at when they're writing the detection logic, right? But yeah, it could be any log source, but that's what I would use, yeah.
So you talked about guardrails early in your talk. What are your thoughts on when you're trying to build something that's autonomous and it goes off the rails, like how to recover from that automatically?
Yeah, so there's a couple things you can do. I would start with stuff like max iterations, right? It really just comes back to I wouldn't do anything that's specific to the realm of LLMs. Stick to vanilla software, right? Whatever you want to call it. Still deterministic systems. Like if you're working with agents, for example, max loops, max iterations, pydantic stuff like that. Schema structure validation is really helpful with this, right? So you could use that instead of a human for validation at the end. But I think that should be a good coverage for that, yeah.
I'm curious, I really like kind of the aspect of focusing specific LLMs on specific parts of the product, or the process, sorry. Do you have a philosophy in terms of how to wrap it all up together? You just mentioned number of iterations, and the part of my brain is thinking like, well, it's Python loop, right? Like just the script that kind of orchestrates the whole thing. Is there some interesting kind of points of views around using LLMs to do the orchestration? How do you kind of put it all together?
Yeah, that's a good question. So the thing about this whole Gen AI explosion, it's a little overwhelming on the amount of tools out there that do stuff like that, but you put it perfectly. It's really just orchestration is what we're doing, right? My philosophy for this is I always kind of want to see, I call it like the last mile prompt. So when people use those tools, they kind of introduce a lot of accidental complexity. And you can see this yourself, but I always want to see the last prompt that's going to the model, because you'll find, oh, I'm using this tool, I'm getting really cruddy results. The tool might be causing some issues. But LangChain is a very popular library for working with these. Check it out. You'll get to a point where you're like, hey, do I want more visibility and control or not, right? But for this, I typically would tell people to start with a tool that's good for fast prototyping. Like, I just want to see if this thing's going to give me some results really quick. Flowwise is a good one. It's like a low-code UI thing. But if you're a programmer and it's quicker and easier for you to do something like in Python, I would just do it with that. Really nothing fancy here. So, yeah.
Okay, I had another question. Is there room for you to tell it how to interpret the logs? Like, say I have like Zeek logs or something, and I want it to like interpret logs in a specific way.
Yeah, yeah.
Like rather than just like giving it the logs and saying like, okay, write a detection. Say like, all right, I want you to write a detection for this specific thing or like that or.
Yeah, so what I typically do is, remember, we're working with these pre-trained models. So like GPT-4 is probably trained up to November of last year, right? The data sets they use for these, it's public data on the web is indexed, it's crawled. So like it knows what Snort is or Splunk or Zeek. It might be really familiar with the logs actually. Stuff like open source tools that were on the web, it knows what those are. Just try and see what the pre-trained model can do. And then whatever it can't, it's fine, but that's just your job as the engineer to fill in that context. So for your example, you could be as explicit as you want. Just think in your head, like when you're an analyst looking at Zeek logs or whatever, what are the things that you look at, right? And augment that with like, here's an example of this field description from the log documentation stuff like that, if that answers your question, yeah.
Oh, thank you.
You were talking about cost. Have you done like a self-hosted LLM?
I have not.
Okay.
So, yeah, we were talking about this yesterday. It's a very good point. So, like, if you use the OpenAIs, the Anthropic, even the smaller models, what's the alternative? Why don't I just use an open source model, free licensing costs like Llama, right, and run it myself? I don't know off the top of my head. I'd have to look on what those numbers actually look like. But if anyone's done that, I'd be really curious to know. Yeah.
Great talk. I had a question, sort of a follow-up from Max's question about orchestration. LangChain is a pretty popular paradigm. Have you worked with DSPy at all?
Yes. So DSPy, for the audience, I would consider a more experimental tool. It's a great concept. So if you think about what we did today, like we're here like manipulating free-form strings. It's not a very scientific, objective way to do this, right? And so a tool like DSPy, it really just optimizes all this. Like imagine you could use it. There are a lot of tools out there. Check out TextGrad. My favorite is Addleflow, which is built on top of those. I would use that. It's very user intuitive. Yeah, but imagine we have this pipeline. The tool will look and optimize all your examples. Are they the highest possible quality examples? Is it the best possible prompt based on your use case? So,
yeah, great. Thanks.
Thank you. So you show this division of labor with understanding the thread, understanding the data, the tools, and so forth. And if I understood correctly, I mean, you pretty much have a separate, I don't want to call it a model, but a separate task or subtask. Would it be actually a prompt per category?
yeah, yeah,
So it is basically 8 prompts or something like that
exactly.
for
yeah.
every single detection.
Yep. Oh, not for every, yes, exactly. So think of it as just like a data pipeline. The threat intel is going through all these steps. Each step has a prompt, sends it to the next prompt. Yeah.
Okay, yeah. Well, that's great. Thanks.
Hello, thanks for the talk. I'm curious, differences between prompt chaining and like mixture of experts type structure to these applications.
Yeah, that's great. So, prompt chaining is the thing we showed today. Prompt 1, prompt 2, prompt 3, mixture of experts. And if I'm, correct me if I'm wrong, but I think it's like putting a specialization framework around different models. So like expert threat hunter, expert log analyst, expert, right?
Yeah,
That's
exactly.
Use that framework when you're building. That's an excellent way to go about this. So you could be using agents, you could be using separate prompts, but both are great. But it all comes down to that point of spend the time to carve out one small specialized task. It's hard sometimes, right? But yeah, that's a great approach.
Thanks.
Thank you. Thanks, everyone.